Okay, I think we should be... Your event is starting. You are live. Okay, this is good. Perfect. Why did it hit? Oh, it synced to the preview. There we go. Okay. Good evening, afternoon, whatever it is for you all. First few awkward seconds there. I'm still looking at the delayed preview. Not in the studio today. Studio is a bit of a mess. I've been doing some remodeling there. So yes, this is my office workspace, whatever you want to call it. I did the Prusa what was it? Prusa control video from here, and people were like, "Ha, this edge right there. This looks weird. What is that?" It's a monitor that's like half in screen to give you a bit of reference where I am. But yeah, lighting is still weird. Lighting is different. Don't worry about it. It's just for today, just for you guys. I did have the webcam on here. Little Logitech C170. That looked horrible. Not up to my standards. All right, so Patreon Hangout for August. Well, it's if I look at my calendar, it's not quite August anymore. Sorry. Last month has been like not crazy as in crazy stressful, but crazy as in like so much stuff I sort of had to deal with and had to figure out for myself. So we're doing the Hangout now in the beginning of September. We're going to do another one later this month to even things out as usual. So yes, let's jump into questions. So as always, I do have the YouTube live chat open on the second monitor here. So if you have any questions live, if you want to throw those in, you can do so. Just ask those. I'll try to answer those first, and if we run out of questions there, I'll jump back to the Patreon post that was posted yesterday, which has basically the question from everyone there. So someone was asking Andre as why no more streams on Sunday? No more streams on Sunday. Well, I am still doing streams on Sunday on the main channel. The only thing is right now the videos I have queued up are the Ain't A8 build, the Tivo Tarantula build, Printabot Simple build, and the Tiny Boy 2 or Honey printer, which is a, I don't know, rebrand or something like that. And those all take so much time, and like we've been in training with our dog just now, and it was late, and then, you know, it's longer projects that I want to do right. So until I get those right, this thing is probably annoying. I don't just want to throw out streams randomly that kind of don't have a good conclusion. So yeah, we'll get back to streams. Just no stream today until I have a proper what do you call it? Environment set up, whatever, everything. So I already saw some nice comments on the Patreon post. If I can find it, I should have a screen cap here. Let's refresh this. There's 4 questions. I thought there were more. Hold on. There we go. Yes, that looks better. Okay. I should also, if I find the right window, this one, I should also be able to switch to the screen cap. Yes. Using. Let's start with the. Well, let's start with the ones I've actually read through and I think are, you know, worth answering. So let's start with Francisco Bischoff. Hi Thomas, I have an original Prusa i3 Mark II. It has the TR8x8 lead screw, so that is oh, I have no hotkeys here. Cool. So that is the 8mm diameter by 8mm pitch. So one rotation moves the entire Z-axis up or down by 8mm. And he's asking, he read about optimal layer height and it should be a multiple of my stepper steps. So basically the resolution, the physical resolution you have. 200 stepper steps and the lead is 8mm. Should be a multiple of 0.04mm, right? but is this really relevant for lead screw ZXs like Prusa that are never switched off? And that is a good point, and that is also a point of a lot of discussion that's going on. The thing is, it depends. As so many things, it all depends. It depends on how well your stepper driver is matched to your stepper motor. It depends on how well microstepping works in that sort of setup. And it also depends on external factors like, are you using auto bed leveling or mesh bed leveling, which the Mark II uses, the original one. And my understanding and my beliefs, I don't want to talk about beliefs here, but my technical understanding is the multiple of physical steps matters to a certain extent if you're not using auto bed leveling, tramming, compensation, have a probe and you probe your surface, because well, if you don't have that, if you just have layers that are always parallel to the bed and the Z-axis doesn't move within one layer, so it stays at one height and the XY just moves, yes, your Z-axis is going to have those discrete, those quantum positions, quantitized, yeah, positions that is like 1, 2, 3, 4, counting up the layers right there, and that's always going to be a multiple of your micro stepping resolution, though the perfect steps are always at the half step, I believe, positions. However, once you add something like auto bed leveling, you're not going to be aligning those steps, those full steps, every single layer. So even if you're not using, or let's say you are using a multiple of those 0.04 millimeters, because you're slightly tilted, you're basically printing on a slightly tilted plane. This layer right here, this is going to be at 0.04. Technically, the next one is going to be at 0.78 maybe. So it's not even landing on that full step. So you are integrating, or you are adding a bit of dithering, basically, aliasing, anti-aliasing. You are adding one of those things to that Z resolution if you're printing on that tilted plane, which bed leveling is. The thing is, with the original Prusa i3 Mark II or Mark IIs, I have so far experienced very good results with all the built-in profiles with Slick3R, and those do include a 0.045 millimeter layer height. Yeah, so 0.05, that's the smallest one, and that's just slightly bigger than the 0.04, but it prints really well. So I believe Prusa has somehow tuned out, or tuned the stepper drivers to the motors well too, and that certainly does help. So to sum things up, most of the time you shouldn't worry about it. You shouldn't worry about those multiples of the physical resolution. There can be some issues if you have a system that is, not well tuned at all, but most of the time it doesn't matter. Don't worry about it. All right, I'm hoping that answered that. Let's just check on live chat. So 3D Printing Meathead is asking, some boards with funny stripes. Some boards print with funny stripes on the print. Too many windows. Not well prepared, I'm sorry. So is this caused by noise interference? Do higher quality boards have components to smooth out the signal? No. Again, that if you're saying stripes on the part, so that would be a regular pattern in the Z direction. Again, that is that interference pattern where you're landing between full steps, and that is simply a worst case scenario where your stepper driver is not matched to the stepper motor well. Typically, like the rule of thumb I use is the Allegro A4988 like to use the high current low inductance motors, and the Texas Instruments DRV8825 like low current high inductance motors. You can just get them in different types, and the common ones are actually the high current low inductance ones. So typically they are going to work better with Allegro drivers than they are going to work with TI. the trinamic drivers work well with pretty much everything. They're pretty intelligent. So, hoping that answers that in the fullest extent possible. 10 minutes, one question. Cool, we're not going to make it through all of these. Paziel is asking, will I test any form Futura filaments on Filament 2.0? Very interested in the ASA and PETG. Yes, maybe. I don't know. The list of all the filaments, I think I've linked it in a few different spots, but there is a full list of all the filaments that are queued up, and it's almost 100 filaments long. So I'm probably, understandably, I'm not very keen on adding more filaments to that list, because at the current pace, if it's like 2 filaments per week max, and that is really pushing it, it's still going to be a year until I make it through all those. So I don't know, maybe not add more when it's not necessary, but when there are interesting filaments, I'll certainly consider them. The other thing is, what is your situation on the Mendel 90 project? So that is my beast of a Mendel 90 that I had built. Wow, it's been a while. It's been like 5 years, I think. Maybe even more since I built that big black Mendel 90 that I did make a video about. Just a recap on just before I disassemble it. It's almost at the position, at the status where it might work again, where it might print, but there are a few details, and it's sort of in a corner, almost finished. It's one of those things that I kind of just have to pick up and finish at some point, but it's coming along. It's getting there. Another question from Andre for the CNC Mill 1. Am I still working on it? I am. I have not worked on it yet, but Z-skin. What? I'm still working on that. I shouldn't show you how much people are pledging. Patreon just sucks there. Am I still working on that? Yes, I will get back to that. I have not worked on it off camera, but I fully plan on like doing a quick live stream again where I actually get it working. And I do want to make use of it because it feels like a really nice machine, and a solid CNC mill / router is a really great tool to have. And the second part of the question is, am I going to test other CNC mills and lathes? Well, CNC lathes, that's going to be interesting. But maybe, yes, we'll see. Maybe laser cutters. I kind of, again, I keep mentioning this. I do want to evolve the channel away from just being 3D printing to more of a maker fabrication style thing. So, yeah. Eventually, though, again, if you've watched the last full video, I kind of want to get away from that entire review thing, at least until I sort things out here with how to handle them, how to morally correctly do them, how to balance the efforts. I will be talking to all 3DP soon. I've worked with them in the past. Maybe we can like collaborate on something. We'll see, but so far reviews have really been dragging me down because it's always this, this barrier of, okay, I have to like work with this thing and somehow get it working even though I don't feel like it, and then writing it and filming it and then filming B-roll and editing it all together. It's like at least 3 or 4 times as much work as a guide. The reviews typically only get a third or a fourth of the views of a properly done guide, and it's like, effort to reward. I've posted about this before. It's just off. So yeah, reviews, maybe not, maybe use them in the project or something, but not as a full review, at least not soon. Right, Paul Arden is asking about the entire aluminum bed situation. So some aluminum beds warp. I've seen that in the past, with especially the thinner aluminum beds that are just, I don't know, the 1.6 ones that are just as thick as a PCB. Those do really like to warp over time because the glass fiber, the FR4 on top, there is a thin layer of that typically. and then the copper on top of that, it just expands and contracts differently, and it warps the entire thing over time. Not a good thing. If you have auto mesh bed leveling, it kind of compensates for that, but yeah. And basically he's asking, by the way, cheap PCB heaters are much worse than that. They just, I've done some measurements, and it's been like a few millimeters that they actually warp when power is applied versus when power is taken off. So yeah, aluminum already better than that. But he's asking what's a better solution would be for that. Some suggest just stitching 3D printed beds and using a MIG-6 cast aluminum plate, 6.35. That's an eighth of an inch, I believe. Eighth, fourth, quarter inch. And a silicone heater. Feels like on push style printers that might be too much weight. Thermal mass would also be pretty huge. I would imagine. No, let me disagree with you there for a second. So a 6.35 millimeter, let's just say 6 millimeters or quarter inch is that much, and it's aluminum. So you kind of have to compare that to the other solutions that are out there. If you're comparing it against a PCB heater, so like a Mark II heated bed, plus a glass sheet to keep it flat, it's probably even going to be lighter, because aluminum, again, it's not that much thicker. You are going to be using like a 3 or at least a 4 millimeter glass sheet for regular sized beds. So 4 millimeters of glass versus 6 millimeters of aluminum. The aluminum, I feel, is lighter. I don't have the numbers for it, but I think it's lighter. Yes, it's lighter. So weight is not an issue. Thermal mass, also not an issue, because aluminum, first of all, aluminum doesn't have that much of a thermal mass, and also it conducts heat very well. So whatever heat you push into that silicone heater, it immediately gets transferred into the aluminum, and it spreads there. Instead, with glass, you basically have that heat build up on the bottom, and it takes a really long time to migrate through the glass. So thermal mass also not an issue. So yes, if you have the option, it doesn't need to be like MIG-6 cast aluminum plate. It can also just be face milled aluminum. You can get that in sheet form. So I don't know. You can also get that in sheet form. It doesn't necessarily have to be cast, but cast is probably the best, because the cast material doesn't have any, or it doesn't have non-uniform internal stresses that are going to, relax when heated up, when it sees those thermal cycles. My headphones are sort of blurring stuff out. Let's turn those down. Yeah, but again, cast, if you can get it, is probably the best. Not necessarily, though, as long as it's flat and milled, that should be okay. On chat, Part-Time Ronin's asking for non-cast aluminum plate, what minimum thickness so it doesn't warp? You can't really, there's no like set minimum thickness. It's a very fluid border, blurry border between getting some warp, getting some flex, and getting no flex. It's not as long as you have aluminum on there, I believe it's not as bad as a PCB board. Aluminum is already a win. I like to use, well, at least 5 millimeters for like a regular sized 200 by 200 or 204 by 204 millimeter bed. 6 millimeters seems a bit overkill. I have used that before. 6 millimeters is like super massive. I don't think you need to go any more than that, or any thicker than that. 5 is okay. 4 probably gonna work fine if it's a rolled aluminum, so that the standard type that it can get is flat sheet. Maybe 4 might not be enough, but that's just the sizes that you can get. Typically, it's quarter inch or 6 millimeters that you will find as cast and milled aluminum. I've used that on the Cerberus Reborn, the big Delta that I've built, that I've designed and built, and it's fabulous. It is absolutely amazing. If you can get that, it's probably one of the best upgrades you can make. If you also add the powerful silicone heater, it just makes your life so much easier. Right, let's check up on chat. I think I missed one. You guys probably worked that out already. Okay. Yeah, firmware board cables plugged wrong. Yeah, Brian Bishop was asking, let's just pull. This is going to be weird because you're going to be seeing me as a delayed version for a bit. Sorry, okay. Where did he go? His print bed started heating up as soon as he turned on the power. Can I? Oh. Now I can zoom, but it doesn't. Sorry. As soon as he turns the power onto his printer, it heats up and it's not in sync with temperatures set in Simplify 3D. It just keeps heating. Is this a bed or a board issue? So yes, let's get this back. This is probably really weird to look at. Yeah, this is definitely a board issue. The bed either heats or it doesn't. The it heats situation would be everything's fine. The it doesn't situation would be either a short, which means you're going to have some fire and flames, or an open circuit, which means it wouldn't heat at all. So when the bed heats, it's fine. The bed is fine. It would be a board issue, which means you either have a MOSFET that is short, that basically is shorted internally, or you have a firmware configuration issue. So the firmware outputs a signal to that MOSFET that it shouldn't get. It could also be a wiring issue, like you have your bed actually wired up wrong to the wrong signals. You should always be using those two output terminals on your board, because the way it's wired up is it's always so loads on your boards, whether it's a heater cartridge or a bed or anything, one side is always connected to positive, so 12 or 24 volt positive, and the other is actually switched or pulled down and then released up to the 12 volts. So when you measure any voltage on that bed, when it's turned off, it's always going to read 12 volts over ground. So yeah, if you wire that up wrong, if you have a short somewhere, it might just heat. If it's connected to ground somewhere, like if it's touching an aluminum bed or some part of the frame that is grounded, and the other side is just regularly connected, then it is also going to heat permanently. So yeah, just make sure that is wired up correctly. Again, ground on the bed output is not ground. That is actually the switched output that gets switched between ground and the 12 volt voltage potential, and the other side is always at 12 volts. So double check wiring, just to clear that up. Okay, and George Robles is Robles is commenting. Usually the MOSFET is obviously blown. Not always. MOSFETs can silently fail internally, and typically they fail in the conductive situation, conductive state. So and once they do, they aren't going to blow, because they are not wasting any more power. They're just completely welded conductive internally. So yeah, that's not necessarily something that you're going to see. Let's check back on the comments on Patreon. Okay, you guys are helping each other out. That's great. I'll try that. Okay. Printing non-plastics like chocolate or pasta. Any insights? Don't want that pop-up. Any insights? Yes, I've insights. You need a paste extruder. You're not going to be printing filament, and just check what other people are doing. Rich Rap's made some great posts. I don't know if it's been videos, but he's made some great posts, and I think he actually designed a paste extruder himself. Is it still richrap.blogspot.org? I believe so. Someone's going to post a link in the comments or somewhere. He's made a paste extruder and basically explained the entire thing. I've talked to the Boccosini guys, which are printing, I believe, chocolate and potato puree and like, is it puree? Mashed potatoes. Printing all sort of that pasty stuff, and they're doing some nice stuff. Yeah, insights. It works. It's not even hard to pull off. So, hope that answers that. Justin is asking, I made a dolly clone using Rams and Marlin. It can only reach 70 degrees constant on the heated bed. What's causing his limitation? Resistance is 1.4 to 1.6. Is that normal? That sounds about normal. Though it's a bit on the, yeah. Okay, so let's see, 3mm MK3. So that's, I believe, an aluminum board. Resistance range is 1.4 to 1.6. So let's just grab the calculator. Let's do some math. So let's say you have a 12 volt supply and you have a resistance of 1.4 to 1.6. That's 1.5. That means it's drawing 8 amps. 8 by 12, that is 96 watts. So that is on the low side. Typically these things are like 1 ohm or so, which means it's around 150 watts. So yeah, you are getting less power out of that bed, out of that MK3 bed, than you would usually. Again, typically they're around 140 or 150 watts with 12 volts. And that could already explain that offset, though 70 degrees is fairly low. I would check. Well, first of all, you're using a cheap RAMs, which means it's going to have a horrible MOSFET. So that's going to be wasting a bit of power. Unfortunately, the MOSFET is probably going to get hot. As long as it doesn't blow, that's fine, but it's still wasting precious voltage, which again, if you have less voltage, you have less current, you have less power to the power of 2. So you probably don't want to change the MOSFET. What you could do is, if you're using a cheap power supply, if you look at the input terminals, I don't think I have one here, no. But if you look at the input terminals on your power supply, like the screw terminals, there's typically a small potentiometer on the side there. Grab your multimeter, read the output voltage on the power supply, and just crank up that potentiometer, and you will probably get it to around 14.5 volts or so from the nominal 12 volts. And that can make the difference between a heated bed staying at 70 degrees and successfully heating to, I don't know, at least 95. I don't want to promise 100, but 95 or so. And that should allow you to print ABS and ASA and those sort of materials. Just a hack, more of a hack than a real solution, but something to try at no cost before you start adding like beefier external MOSFETs, etc. That will reduce the wasted power on your board. That's just something you could do for free, and maybe it works. Right. I'm losing track of chat, but I think you guys are good. Yeah, Rapid Tables has a great watt calculator. Yeah, I mean watts, amps, voltages, etc. Isn't that hard to calculate? Would I be able to look into and review the Zesty Nimble remote direct drive extruder? Again, no new reviews, no reviews for now. At some point, I've been asked about the Zesty Nimble a few times, but unfortunately for now, sorry, no. Have I ever thought about buying a laser cutter as an expansion to 3D printing and upgrading a printer to a small CNC machine? I've actually made a pretty popular video about that that got featured in Hackaday about upgrading the Mendel Max 3 to basically a Dremel based CNC router. And so yeah, I've done that. I've done that thing where you upgrade a 3D printer to a CNC router. mill, whatever it's called. So yes, done that. It's not the greatest CNC in the world. It's actually pretty shitty, but wow. Another idea to make videos about operating, setting up a laser cutter. Yes, that could also be quite interesting. I do have one of those ghetto, what is it, like 10-watt laser modules. I'm still. The thing is, I've got that. It probably wouldn't be that big of a deal to set up, but I am legitimately scared of that stuff. I am scared of laser cutters already somewhat, but like the industrial ones where you have the lid and that's all fine. But when you have like a laser that like actually when you touch it with your hands, it's going to burn a hole in your hand. If you have that in like an unenclosed space, and you always have that thought in your mind, okay, I've bought these laser safety goggles that aren't actually laser safety goggles, but kind of seem to work. What happens if it hits something reflective and it just shines into my eye? I am somewhat self-conscious about having two functioning eyes. I don't plan on changing that. So yeah, I have everything I need to make guides and to turn something into a laser cutter, but I'm just scared of it. It seems a bit too risky. And the other thing is, with me showing it and maybe not putting like the full amount of like safety disclaimers on it, if someone else does it, blows one of his eyes out, am I gonna be in charge? I don't want to be in charge of that. For obvious legal reasons. So yeah, I'll have to look into that. Not looking forward to it at the moment, unfortunately. All right. Can a smoothie board play better with microstepping to make the stepper motors quieter? I don't know what you mean by play better with, but does it depend on the motor as well? Yes. Can it depend on the firmware? No. Can it depend on the G-code? No. Okay, let's go through that. Microstepping, I've explained that a few times before. And the question is to make the stepper motors quieter. That mostly, if all you're going for is noise level, then you're pretty much, well, the smoothie board has the fixed Lego drivers. They are soldered onto the board. You can wire in external ones. It does have the solder spots where it can actually attach step direction, enable, etc. pins to an external driver. But stock smoothie board, Lego drivers, they're fine, they're okay. It's basically just adjusting the current until you find a value that is silent enough for you. You can't really adjust anything else, that's the thing. His next part of the question, let's just go through what it all can depend on. Again, current, yes. Does it depend on the motor as well? Yes, it depends on matching the current to the motor you're using. Can it depend on the firmware? Well, as long as you have smoothie board, you don't really have a choice there. But no, typically the noise level that is depending on microstepping is not dependent on firmware. As long as your firmware can consistently output step pulses in like a consistent manner, it's going to be like the maximum silence, the best possible performance for noise you can get, and most firmwares do that pretty well. So that's not an issue. And lastly, can it depend on the G-code? Well, okay. The noise your 3D printer makes can depend on the G-code. The noise your 3D printer makes just because of microstepping and because of the physical stepper motors is not going to be affected by G-code, but it will be affected by how the G-code, the general noise will be affected by how the G-code is set up. So for example, you have some very fast, tiny moves. Some slices have the option to limit the frequency or the speed the printer changes direction. So instead of like getting into a resonant into a resonant mode, where it just goes like and just shakes back and forth. Some slices can limit that to go like very slowly on that section to reduce that resonant frequency. That's the only part where G-code can make a difference. That's a good one. Jamie is asking, he got a set of replacement nozzles for the Maker Select V2. That seems to be a pretty popular machine. So he has basically 0.2 to 1 millimeter nozzles. Should he just start experimenting like crazy, or are there some speed and extrusion rules he'll need to keep in mind? Right. There are, I don't want to say that there are rules, but there are rules of thumb. So let's start out with the crazy one. 0.2, you're probably not going to be making much use out of that. It's really slow. It likes to clog really easily, and it's really hard to cool. Why am I yawning? Excuse me. I had a good night's sleep. Whatever. So yeah, 0.2 really gonna be a beast to cool your print adequately, especially if you're printing PLA. So let's just get that one out of the equation. 1 millimeter that's a fun nozzle. The limitations you have are, first of all, with the smaller nozzles is the resolution of your extruder drive. So you have your filament, the extruder drive, is pushing it at a fixed rate. I think the monoprice Maker Select is actually a Bowden, so that doesn't matter that much. That could be something that's limiting you with the really tiny nozzles, 0.2, 0.3, maybe not so much, but yeah, you're just gonna get inconsistent extrusion instead of a continuous flow. It's more like blob, blob, blob each time the motor takes a step. On the top end, you're also going to be limited by the extrusion force your extruder can put out, because you have to push a lot of filament if you want to print at the same speeds that you'd usually do with a 0.4 millimeter nozzle with a 1 millimeter brass nozzle. So that might also be a limit for you there if you're getting skipping extruders. Maybe try a higher temperature. That's, if your hot end can keep up at all, try a higher temperature, like 10 or even 20 degrees, and print slower if you have to. But generally, rules of thumbs: how do you get a good extrusion or a good setup or slicer profile for a specific diameter? So what typically works is, you have a wide range. What typically works for me is basically keeping feed somewhat consistent, which, to be honest, I like to print on the slower side of things. So that is 60 millimeters per second max for stuff like infill, and then 30, 40, somewhere around that for the finer details, for perimeters, for bridges, etc., etc. So print slow, that always improves your stuff. You can always go faster, but you don't want to start out too fast. And then when it comes to extrusion width and layer height, so extrusion width, most slices calculate automatically these days. It's usually exactly your nozzle diameter, or maybe 5 to 10% higher. So with a 0.4 millimeter nozzle, you'd have a 0.4 millimeter extrusion width, up to maybe 0.5. That would be pushing it, but maybe 0.45 or somewhere around that range. That's usually fine. Layer height, what I find works well, or works best, is about a quarter to half of your nozzle diameter. So with a 0.4 millimeter nozzle, you'd be using 0.1 to 0.2 millimeter layer heights, and that generally gives you a good compromise between just stuff melting down, so cooling issues. With the smaller layers, you have a lot of cooling that you need to keep in mind, a lot of cooling issues typically, and overhang performance. So if you have a very wide, no, no, okay. If you have a very slim extrusion width, so say you're using a 0.2 millimeter nozzle and you're pushing 0.2 millimeter layers or even 0.3 millimeter layers, you're going to have an extrusion that looks like this. Exaggerated. You're going to have something that looks like this, and if you put like the next layer on top of that has somewhat of an overhang, it's not gonna have anything to sit onto or to stick to. So one layer right there, the next one over here just droops down. On the other hand, if you have it flat like this, which is like a 1:4 ratio, you have one here and the same overhang angle, 45 degrees roughly, it's just gonna have that much of an overlap. So that's gonna be a three quarters of an overlap from one layer to the next versus just nothing. So that basically dictates how tall your layer heights can be. You can experiment with layer heights that go up to maybe your nozzle diameter. So 0.4 can print up to 0.4, but it's not going to look great. Typically, again, what works best is 50% to 1/4 of your nozzle diameter as layer height. And then extrusion width, just keep that constant. Speed, again, try low first and then go. And yeah, with the larger nozzles that push more filament, try a bit more temperature on the hot end. All right, I think those were some really good questions. Let me just take a quick scroll through what could also be interesting. Nice friend, thank you. Picture frame, what? So temperature question, enclosure for a 15.6 inch screen, it gets up to 40 degrees Celsius. Well, when you enclose it, it's probably going to get even hotter. I wouldn't risk it with PLA. I just go with PETG. It prints about the same as PLA. It's not much more expensive. Just use PETG and you know, be safe. Any more thoughts on the camera slider project? I've seen some comments of people saying the LCD libraries, etc., are a bit flaky and they don't always work. I know they work for me, but again, if you have cheap hardware, that can vary quite a lot from one order to the next. It can crap out. Yes, eventually I do want to work on that, but it's not one of my focus projects, which ties into Matthew's question. Do you have any nifty project in the works? And I guess to end this one, yes, I do. I've Atom 3D or Layer 1, the guys behind the Atom 3D printer, they've been wanting to sponsor projects since, I don't know, a year ago almost now. And we're finally getting there. There is some nice stuff coming up that is like bigger projects. Actually looking this way right now because that's where one of them is going to go. It's going to be some nicer, practical, bigger projects that I actually need. Again, that's stuff that's actually useful to me. And yeah, that's coming up. Also, like smaller stuff. I just want to make use of the tools I have and show them in a project, in a real world use, instead of just reviewing them in what can be quite a vacuum. All right, I guess, and that that concludes it for today. I'm hoping the lighting wasn't too distracting or too weird for you. This is just what I have set up here. This is my office lighting. IKEA, not free, with the adjustable color temperatures. Oh yeah, look at that. Now all that's illuminating me in cool white is my screens. Yeah. Hope that wasn't too distracting. Audio should have been good. And again, for all of you watching, thank you so much for your support on Patreon. Again, you're creating jobs. You're like good for the economy. You're good for content. You're good for 3D printing content, I hope. All right. That's going to be it for today. Thank you all for stopping by. It's been 45 minutes. Wow, nice. Again, there will be another Hangout later this month because I'm kind of late with the August one. So yeah, I will catch up on that. Maybe in like 3 weeks or so. I don't want to like do them too quickly one after the other. Right. So that's gonna be it for today. Thank you again so much for your support. Keep being awesome. Keep making stuff. Keep fighting the good fight. And yeah, see you all in the next Q&A session on Patreon and what else? On YouTube. See ya.